Coming up on this episode of the IoT Inc. Business Show.
It's a protocol that runs on top of the internet, and the protocol could be used for a lot of applications involving identity, assets, and data. Blockchain is a set of algorithms, certainly those underlying Bitcoin, but can be used for many other things. It involves distributed ledgers instead of centralized databases. It relies on cryptography to link blocks of data in what we call unbreakable chains.
There's an evangelistic tone surrounding blockchain, and if you believe some of its biggest preachers, blockchain will completely change how the internet, and by association, the Internet of Things, will work, and in the process will change the world. When I find myself slipping into this worldview, I shake myself back into reality by looking at it from a business perspective. In this episode of the IoT Business Show, I speak with David Snyder to better understand the tech in order to better understand the business opportunity blockchain presents.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is for business leaders and managers employing the Internet of Things for their business or the business of their customers. I'm your host, Bruce Sinclair, and I interview the industry's leading authorities to find out how they use IoT to improve business and create value. If you like this show, subscribe to it on iTunes and go to iotinc.com to check out my complimentary articles, videos, meetups, and webinars. Before you listen to this episode, I have a disclaimer to make. I'm not satisfied with the way it turned out. I don't feel it moved us that far forward in this particular learning journey. There's a certain level of information density I strive for. Like you, I don't have time for fluff. And as everyone who listens to this show on a somewhat regular basis knows, even though we're ultimately concerned with the business of IoT, it's my view that we need to really understand how the tech works in order to put it to use. Lightweight managers and execs don't understand it. Heavyweight managers and execs do. In this episode, the guest didn't really know blockchain tech well enough, and that's my fault. My fault because one of my main responsibilities here is to properly vet my guests so your time with me is well spent. There's still value here, but not as much as what I think I generally deliver. I'm not sure if that's a good or a horrible transition into my next topic, my upcoming IoT certification program. Either way, I can assure you that the entire program that's broken into 3 courses, tech, business, and strategy, is dense and without any fluff. It takes everything I've learned in IoT and packages it online so you can learn it at your own pace within your own busy schedule. I've got a good group started, but I'm still looking for another 10 or 20 beta students to go through the program to provide me feedback before I open it up to everyone else. If you're willing to participate in exchange for a greatly reduced price, contact me at bruce@iot-inc.com or just go to iotinc.com or brucesinclair.net and contact me with the Contact Me form. That seems to be the way that most people are doing it. And with that, I give you more blockchain and IoT with David Snyder. With me today on the IoT show is David Snyder. He is president of the consulting company 42 Tech, where he helps organizations develop and implement new technologies. His experience including with Apple, Google, Kaiser, PayPal, Yahoo, startups. David is investigating methods for using blockchain technology to ensure data quality and security for IoT devices, including remote patient monitors and environmental sensors. David, welcome to the show.
Hello.
Working on lately? What were you working on just before we started talking?
Well, I'm actually starting to toy around with some Arduino kits for Internet of Things sensors, just so I can get into maybe a little prototyping.
Oh, so you're actually pretty hands-on then.
Haven't been, but we'll see.
Now, is there any possibility that the Adreno kits would be able to run blockchain, the ledger technology?
No. I don't see that. I see blockchain as a different layer, and we can get into that as we talk.
So the computation isn't happening, I guess, on the edge, so to speak. It happens remotely within the cloud?
Yeah, well, I don't know that an Arduino kit, I haven't got into it deeply enough to know whether it could be a node. Certainly not on a public blockchain, but it's possible that may be able to figure out some devices that can talk to each other. Like I say, I'm getting into that part of it. I've got the mental model worked out. Now I'm trying to go a layer deeper into what it's really going to take.
We're looking forward to hearing the mental model. Quick question, though. Is the difference between a public blockchain and a private blockchain simply just, private or public network, or is there more to it?
Well, there's more to it. It has to do with the way consensus is maintained. Is probably the simplest way to say it.
And so consensus just in a private blockchain being those that are designated, and a public anyone, or what do you mean?
When we say consensus, we mean how do we keep all the copies of the distributed ledger synchronized so they all have the same information. In Bitcoin, and which is a public blockchain, there is a mechanism that involves proof of work, which is very computationally intensive. And so you have what's called Bitcoin mining to do those calculations, and it's a competitive process and it's complicated. In a private blockchain, there are simpler methods for keeping copies of a database in sync, where if you already have a certain degree of trust because only certain people are allowed to have access, you don't have to go through quite as much. You don't have to have as much work done as the proof of work in Bitcoin.
Okay. So the algorithms for this consent you're saying are different then? That's
correct.
Well, let's talk a little bit about yourself, and in particular your background in IoT.
Well, I've had a varied career. I started back in my college days working as a respiratory therapy technician in intensive care units. But I got interested in the environment and decided getting a civil engineering degree was the way to go. And I did about 20 years in environmental engineering, involved a lot of field work. But I got interested in the internet, and right around the time e-commerce was coming out, and a friend of mine got me into the credit card industry. And of course that led to a lot of data security work. More recently, I've been able to sort of bring together some of that stuff. I've been looking at things in what you might call digital health or health technology, especially remote patient monitoring. And about a year and a half ago, I learned about blockchain and wasn't as interested, it turns out, in the financial technology, Bitcoin-type aspects of it. But there's a lot of potential to bring things together, as you mentioned, with remote sensing, remote monitoring.
So the remote sensing and remote monitoring, you did that as an engineer? Is that where you have a little bit of experience, or where did you get the experience?
Well, thinking about the healthcare situation, when I was in hospitals, many years ago, there were cardiac monitors, and remote monitoring then was a cable running from the heart monitor in the patient's room so you could have a screen also showing in the nurse's station. Of course, more recently, all of that stuff has really become available over the internet. And again, in environmental, we were collecting soil and water samples in the field, sending those to the lab. The lab would analyze it, then they would print out a lab report and fax it to you, if you can remember those days. Now that stuff is being transmitted electronically, sometimes directly from the field. And so I think my real interest around blockchain, you know, when we talk about it a little more, it comes around data quality and security and the data management. There were huge issues both in environmental and in healthcare around data, and I'm seeing some opportunities to do something about it.
All right. Well, why don't we start at the basics? And I'm asking everybody the same question because, quite frankly, it's taking different angles to kind of get to the result. But what is blockchain?
I'm glad you asked. One way, if you need, if you're visual like me, is to think about, a duck swimming on a pond.
Okay.
Smooth movement on the top and furious paddling beneath the surface. It's a protocol that runs on top of the internet, and the protocol could be used for a lot of applications involving identity, assets, and data. Blockchain is a set of algorithms. Certainly those underlying Bitcoin, but can be used for many other things. It involves distributed ledgers instead of centralized databases. It relies on cryptography to link blocks of data in what we call unbreakable chains. There are also algorithms, as I mentioned earlier, to maintain consensus among the different nodes in the ledger. And what you get is an immutable timestamp record of transactions. And transactions are not just exchanges of value, but they can be data record transactions. For example, property records and supply chain. A key thing of what blockchain is it's a foundation for trust among a group of users who want to all interact with this data set. It can also be a platform for executing code. You've heard the phrase smart contracts, perhaps. And there are both public and private versions, or we call them permissionless or permissioned versions. And the private version can be more nimble because, as I mentioned earlier, the consensus mechanisms are simpler. And finally, think of blockchain as something that is really going to be helpful for big data analytics.
Okay, in what way?
Well, from my perspective, when you're doing data analysis, you want to know something about that data. You want to know where it came from. You want to know if it's accurate and precise. And blockchain is a way of recording information of what I call data provenance. So along with your measurement, you can also have information of who measured it, with what instrument, at what time, in what circumstances, what was the context. For example, your measurement of an EKG, it's going to be very different interpretation if you know that it was just sitting at home or if it was in the emergency room during a heart attack.
Right. But now this provenance that you're talking about and just understanding the history of the data, it's not so much unique to blockchain. I mean, we have metadata that we can associate with the payload to provide all this information. So this is more that you can trust it, isn't it? Or is there more to it?
I think that's a good way to put it. When you get into the nitty-gritty of blockchain, the way data is stored uses hashes to connect that data together so that, again, that phrase, an immutable timestamp record. So you may have, on the one hand, a database with metadata, but it's potentially corruptible. If that same data is recorded in a blockchain distributed ledger, much less susceptible to corruption or loss or manipulation.
So I want to dig into this a little bit, and I want to bring into the concept of the protocol, the blockchain protocol. So I'm just now thinking, how do we transport this data, and then how we store in our databases? So what you're saying is there's a blockchain protocol, and that blockchain protocol, I don't know a little bit more about it, but assuming this is the method for, I guess, carrying this metadata that we've been talking about along with the payload. So it's basically all the data. Speak to me a little bit more about the protocol itself.
This is perhaps a little more technical than I'm prepared to go into because I'm not a coder. But my understanding is that when data is recorded into a blockchain, you can record a number of pieces of information into a block, and they are each piece of information is hashed, and this depends on one understanding what a mathematical hash is. It's basically a one-way algorithm that takes a whole bunch of information, whether it's a single number or a whole PDF file, and chunks it down into a 64-character alphanumeric representation. And it's unique to that file, but if you can't take that 64 characters and figure out how to go back the other way, you take a combination of those hashes in a block. So you could have a hash of the measurement and a hash of other information, the metadata, various pieces of metadata. They all go in a block. There's a hash of that block, and the key of chaining the blocks together is that the top level hash of a preceding block is embedded in the beginning of the subsequent block. And if you were to go back and change anything in the preceding block, there would no longer be that relationship. The hashes would no longer be in sync. Does that make sense?
Yeah. So it sounds like for each one of the blocks within this blockchain that are hashed, and hash isn't, again, just so everyone listening, it's not to identify what side, it's to identify if anything's been changed in it, I suppose.
Yes.
And then what you're saying is each of these blocks has data, and I suppose then you could break that data up in any way you wanted. You could individual pieces of data, maybe you could have 10 records, I suppose, and correct me if I'm wrong, in one block. And so you have a string of these blocks that have the data, let's say, for the sensor, just to bring it into IoT terms. And then when this is where I'm trying to understand is the relationship between that protocol, that hold blocks, and I'm kind of starting to skate here, but the protocol that holds the blocks, that holds the data, this obviously has to be communicated over the network from the sensor, let's say, or maybe from whatever, it could be from the sensor, it could be up the chain, further up the OT network or in the IT network. But in any case, let's say it comes from the sensor. So that data, generally speaking, we'll make that our payload and metadata around that. Then we'll put our networking protocol around that and our media protocol for the radio around that. So I think maybe you can help me out here. Then this protocol, is it wrap around the payload, or is it actually the payload itself? Or are you shed any light on that?
Well, I think the way to think about it is a distributed ledger. It's a database, but it's replicated at each local node. And these nodes are communicating with one another to keep everything in sync, so everybody's copy is the same. And that's some of the magic of blockchain, is that whatever consensus mechanism is used, and again, I'm not a coder, so I'm not going to go down into the weeds on exactly how that's done. The other thing that I think is important, and maybe not emphasized enough in our discussion so far, is the use of cryptography getting data in and out of that ledger. I think you're probably familiar with public key infrastructure, the idea of private and public keys.
Maybe you can explain that for everyone a little bit?
At a very high level, if you and I want to exchange some information and have it be encrypted so that no third parties can intercept it and understand it, you would have a combination of a public and a private key. You would let me know your public key, and I would use that public key to encrypt my message. You keep your private key to yourself. When I send the message to you, encrypted with your public key, you are the only one who can decrypt it using your private key. Don't ask me the math on that. It was developed years ago, and it's been a very robust tool for internet communication, SSL, for example.
Mm-hmm.
But
okay, so you're using that cryptography, and then you're then...
Yeah, so your sensor device, not the sensor itself, but the device that has the analog to digital and so forth, it's probably going to have a way to communicate to this distributed ledger, identify itself,
right,
and say, here's my data, I'm giving it to you to store in a certain way, and the blockchain then says, okay, I'm going to store it in this mechanism that ensures it can't be corrupted, and then if you want to come back and look at it later, you can use your private key
right
to see what's in there. And you can give that public key to other people to say if you want them to be able to also be able to look at it.
Okay, no, so that helps. So I think a couple important points here is blockchain isn't a method of security or a method, let's say, so to speak, cryptography in the traditional sense. It's more a method. It's more of a database or a distributed ledger instead of a data that enables you to make sure that you know that nothing's been changed, but it's not actually do security itself other than, again, checking on the change, right? That's the first point.
Well, one minor comment on that. It can be useful for security. And to jump ahead, one of the things that I've been talking about in my presentations is the integrity of the firmware on an Internet of Things device.
Mm-hmm.
If you were to record a hash of that firmware when it's manufactured and then keep that hash stored in a blockchain, then when that Internet of Things device, that sensor device, is out in the field, you could query it, get another hash of the firmware that's on it at the time when you're taking measurements, and compare it to what the hash was when it was manufactured.
Right.
If the firmware has been corrupted, they're not going to match.
Right.
That's a way of ensuring the integrity of the firmware, which is part of, for security, confidentiality, integrity, and availability. So there are uses of blockchain for security. And
yeah, but they're isolated, I think, or what you're saying is they're more focused on the integrity part.
Provenance, integrity, availability comes from the fact that you're not relying on a single database that if it crashes, you've lost everything unless you have a backup. It's much more reliable to have multiple nodes, and if you lose one of those nodes, well, everybody else has got the information as of the most recent consensus, and it's easy to restore.
So going back to the sensor example, when do you actually, in the distributed ledger and the hashing on data, is it done? Is it done just when it gets up, let's say, into the cloud, and then you're about to store it not in a database but in the blockchain, or is it actually done closer to the edge?
That's a good question, and I think it reminds me of the podcast you recently had with Zaki Mannion of the Internet of Things Alliance. And I think one of the things he was talking about is some of the work that's going on and how to find some standards for how to exchange this information. Interoperability among Internet of Things devices is certainly an issue today. And so there's no one right way to get information into a blockchain. And I'm not, like I say, a coder, so I can't tell you the precise ways to do this. Enough to say that a blockchain can ingest messages and store them in a way where it's hard for them to be corrupted. Property records are a great one. We all have to have title searches when we buy a house. But if the property records were maintained in a blockchain, and some governmental agencies are already working on trying this out, you have a more reliable record. We know that in some developing countries, if a powerful political person can come in and say, well, erase that ownership record and transfer it to me, that'd be harder to do with a blockchain record where everybody has a copy.
Right. Well, let's move it again back to IoT, and why don't you take maybe some of the different ways and use blockchain, within IoT itself?
Well, I think I've already mentioned data provenance and device integrity. Mm-hmm. Another way is interactions among devices near the edge, so-called fog computing. There's already a great example in Brooklyn, written up in the New York Times last year, where they've created a network among solar panels on rooftops at different dwellings and allowed those devices using a blockchain infrastructure to basically talk to each other, and if one dwelling needs energy and another one is producing a surplus, be able to actually arrange for the transfer in the grid of that energy. You can even have those devices paying each other by using, for example, Bitcoin. The devices are networked together. They share the information. When certain conditions are met, a message is triggered to say, go up to the Bitcoin blockchain and transfer this much value from this entity to that entity. That can be automated, all near the edge, not actually on the sensor, but in the gateways where the communication is happening. And this is without having to go all the way up into the cloud. This can be more local among a mesh network of devices. And there's some companies doing some things along these lines.
Well, in both those examples, with respect to the solar panels and the Bitcoin traction, these are all defined by the smart contracts. Is that right?
Smart contracts can be a part of it. Certainly the paying one device paying another, that invokes the smart contract concept. But you don't need to think of it as smart contract necessarily if you're just sharing data. I would mention the company Filament, based in Nevada, that has done a bunch with some sensors and devices in a mesh network arrangement. And if you look at their website, they talk a little bit about this sort of thing. The other kinds of things I think that are important for devices is logging events. It's an immutable timestamp record. We always in security talk about having good logs, but then protecting those logs and ensuring they're not corrupted. Well, a blockchain is a great way of doing that.
Okay. So I want to maybe, can you take us into the smart contracts as I understand them? Is, like you said, going to be code, and they're going to be code executed after a transaction occurs. Is that a good way to think about it, and maybe flesh it out a little bit more for our listeners?
We tend to use the word transaction in different ways in different places. You know, a lot of people think of a transaction as a purchase or a payment.
Yeah.
But in data, it really, any kind of interaction. And what we're talking about with the smart contract idea is recording trigger events and having algorithms that are listening for trigger events, and upon a trigger event, then execute some piece of code. It says, you know, in my modest understanding, you know, of code, it's, you know, your if then else. If such and such has occurred, then make a payment from this account to that supplier.
Okay. And this is then going to be done, and what you're saying is this could actually be done closer to the edge as opposed to having to be done in the cloud.
Increasingly, that is becoming a possible, and there are some projects, and for all I know, there may be actually some real commercial applications. I don't know the clients who are involved, but I think this is beginning to be deployed.
Well, why don't we, I guess, maybe shift more into interests you? So where are you seeing where is most of your interest in blockchain technology?
Well, I think you've heard a little bit about it. You know, my perspective is as a creator and user of data, especially in healthcare and environmental. You know, I leave the financial stuff to others. Thinking back to my environmental days, I did a lot of site investigations for contaminated sites. And we'd spend, in some cases, it could be millions of dollars collecting data on how many parts per billion of this and parts per million of that are in soil or groundwater. And that data, you'd have to carefully document how those samples were collected, the chain of custody to the lab, the calibration of the laboratory instruments, and the communication of the data, which, remember, in those days, sometimes was being transcribed by hand. Today, we now, well, just thinking back to what happened in those days, the ultimate outcome was that is, if the site was determined to be contaminated, it could be a cost of millions and millions of dollars to clean it up. And so the property owner would have a vested interest in making sure, like, is that data really true? And you would have an army of lawyers come in and look at the whole process of how the data was collected and documented and the chain of custody and the calibrations. And if they could find fault with it, they'd say, none of the data is reliable. Go and do it again. We don't have to clean up because you haven't really proved that the site's contaminated. Well, we're talking, again, millions of dollars having to be repeated. So I was very sensitized to the importance of data quality and data provenance. And so being able to keep a trustworthy record of the information is something that excites me, along with how it was collected. Data integrity, again, that it, once it's recorded, it's nigh on impossible to corrupt it, and the integrity of the information and the availability that because you have the different nodes and not relying on one central place, that gives you some reliability.
Yeah, I suppose from a database point of view, you're saying.
Yeah.
Right.
So those are the things that, you know, make me want to get up in the morning and do more work on this.
So talk maybe, you know, data provenance. I've heard a few examples, but maybe you can give us an example in IoT where this would be really, really valuable.
Well, I think I mentioned earlier, certainly an EKG reading of a heart rhythm. If you remember, if you were measuring that in the emergency room during a heart attack, it's different than a routine measurement at home. And right now, physicians are very concerned about being inundated with data from whole bunches of devices, most of which that data is really not important from a clinical decision-making perspective. You only want to know the anomalies when somebody's having an arrhythmia. Recording this information in a reliable way with the provenance so that when you go back and look at it, you can say, oh, these are the important data points, instead of just a stream of data and you don't know the context. In supply chain, we're already seeing instrumentation along the way. I think Zaki talked about having a thermal sensor in a container ship, being able to know if something that needed to be kept cool was indeed kept cool for the entire trip. So there's a number of these that are emerging, and sometimes when I give a presentation, I'll put a table up on the screen that, depending on the industry, people are looking at a whole lot of different potential uses where you have to rely on that data not having been corrupted.
And what type of input are we talking about then?
For running a blockchain?
To be able to do one or two examples. Let's say being able to ensure that this medical data has not been tampered with. I think that's where you're going with it, for example.
Yeah.
What are we talking about in terms of an installation? Because everyone listening here is thinking, okay, well, then how am I going to, what needs to be done to implement? So what are we talking about in terms of infrastructure?
I don't think it's a very heavy load. I don't think you would run it on a smartphone, but a lot of our desktops and laptops probably have sufficient capability for a private blockchain. If you're running Bitcoin and you want to be a data miner and that whole thing, then you're actually talking about building application-specific integrated circuits, of which there exist several already, and creating a farm of servers that are going to run the mining protocol, and that's a whole thing I haven't spent a lot of time on. So you may need a lot of computing power for a public blockchain running Bitcoin. But for a private blockchain application, depending on how much data and how fast it's running, I know of some proof of concept things that are running on AWS and with local software to interact with it, and people are able to set those up if they know what they're doing, and this is certainly a point. There's not a lot of people yet who really understand how to code for blockchain, but people know what they're doing. They can set it up fairly readily.
So explain then, you mentioned AWS, and we were talking about database. But is this completely replace a database, or is this adjunct to a database? Specifically the ledger infrastructure that's necessary for blockchain.
Yeah, this is a good point to emphasize. When we talk about blockchain, we talk about distributed ledger. There's the whole point of having blockchain technology or one of the key points is to have trust among more than two parties who are interacting with the data. Everybody wants to have a copy of it. So instead of having to rely on a central authority running that centralized database, everybody has their own copy, And trust comes from the way it's constructed and maintained, and consensus is maintained. And so they're diametrically opposed. In one situation, you store everything in a central database. You have someone who manages that. You rely on them as the trusted party, whether it's a financial institution or a technology company. And in a blockchain situation, it's distributed. Everybody's got a copy. No one is specifically running the whole thing, with the possible exception of, in a private blockchain, somebody has to administer the access management to say who is allowed to have a copy and interact with it.
Okay. So let's go a little further with this. So in IoT, we're going to have a data lake. The data lake is going to consist of the data that's coming from, let's call it, a specific type of IoT product, system, environment. And the data is going to be coming from sensors. The data is going to be coming from external systems. And it's going to be put in a relatively flat structure in a data lake that is then going to be pulled apart in different ways, put into different pools, and then analyzed. So just to break down what we're talking about here is replacing that data lake with this blockchain technology, the distributed ledger. And we're talking that there's different private blockchains according to data. So if this data lake, for example, has sensor data, it has weather data that's coming from external system, then these are two different private blockchains that are being, and the data is with two different groups, let's say, that are part of the private blockchain. So I guess I just want to understand, this seems like a pretty big undertaking, because the data lakes I'm talking about for IoT are literally terabytes in size. And I think
I wish I had a friend of mine who does code for blockchain with me here today, because he's the developer for one of the startups I've been advising. And one of the examples he gives, and they're currently using AWS for their demonstration projects, but they can certainly do this in a proprietary framework for an organization, that doesn't want to give its data outside its four walls. But he made the point that when they developed their system, they knew that one of the potential uses of it would be to collect the data from wearable health monitoring devices. And of course, that could be in the thousands and millions of devices generating signals all day long. I said, well, he's fond of quoting that what they did in order to test the capacity of their design is they hooked it up to the Twitter feed, and they were able to ingest all of that data and store it in a blockchain framework in their proprietary approach, which I don't have the details of. But I have confidence that instead of this centralized model, which can be appropriate in some cases, I'm not saying it's never appropriate, instead of taking all this IoT data from these billions of devices and running it through the cloud into these data lakes in central databases, which is going to put a tremendous burden on the internet infrastructure with all of that data, you can have more local distributed ledger copies where you're ingesting this stuff closer to the edge in a sort of fog computing model, and then query that from the internet and say, all right, well, what do we want to pull up into the cloud? And, local storage is becoming more and more practical. So I hope that kind of explains it. It's difficult to do this without, drawing on a whiteboard, but, and especially since I'm a very visual thinker, but I'm trying to describe doing more of this stuff locally with the great computing power that we now have, and not having to go up into the cloud.
Yeah, but it's a separate issue. I mean, what I was talking about was more storage capacity. And so the storage capacity being in the cloud or locally are going to be the same. So if you're having to have multiple copies of this terabytes of data, that's not really right. It's not really helping in terms of storage. But I think what we
it's helping in terms of traffic, because instead of having to go through the cloud, you can have a mesh of local devices in a factory, or instead of having to go to a central database back and forth to make these queries, you can have the different suppliers in a supply chain. Boeing does this with their parts supply chain for their airplanes. Everybody who's involved in that has a copy of the ledger of what's going on with those parts and the history of when that part was manufactured and where it is, where it's been shipped, where it's been used, and maintenance history and so forth. And so everybody's got a copy of that locally. They can look at. It gets updated frequently, but you're not relying on a single central authority to be the source of truth of what's going on.
Yeah, no, and I think we'll pop up a level because it seems like two kind of trying to feel our way through this. But my elementary understanding tells me that that's true, and it has its place for this providence and for the integrity. But you're probably not going to want to apply your data, because what you're describing here is more less traffic. You're describing having to communicate between all the different nodes that have all the data in the private block, as opposed to having it in one central place. But I think.
Yeah, and again, we're getting down into the weeds of the technology of how the algorithms work, which is I'm not the right person for. But maybe this is a good point to bring up, that blockchain is not to be seen as a panacea. There has to be a business need to be able to interact this way with more than two parties who have to have access to the data, and there needs to be a requirement for trust among those parties, maybe separate entities. And you have to be looking for some efficiency that you're going to get by automating some of these interactions with triggers that are happening off of the blockchain. So it's an enabling technology. It's going to eventually run invisibly for us, much as the way we all use the web, but we don't think about day-to-day TCP/IP. Blockchain, it will be running underneath as a way to have certain things happen, which are going to be advantageous.
Okay. Well, I mean, where do you suggest that our listeners go to dig into this a little bit further? Well,
I've certainly found a few places that have been helpful. I was just looking at some of my notes. There's a couple of websites that are very useful. Coindesk.com is very focused on Bitcoin and financial, but they have some excellent tutorials there on blockchain technology. There have been a number of articles in Forbes, Fortune, Harvard Business Review, and The Economist that talk about the potential. And increasingly, you're seeing conferences and meetups. For example, here in Silicon Valley, coming up November 29th and to 30th, there's a blockchain expo. There's a free exhibit floor pass, and my website has a discount code if you want to attend the whole conference. These events are a great way to start to become more familiar and connect with people who are doing some of the things. And, of course, some online courses are starting to emerge as well.
All right. Well, if you send me some of the links. Coindesk.com is a simple one, but to the articles in the various publications and maybe online courses, I'll include them in the show notes.
Sounds good.
Dave, where can people find out more about you and your company?
Well, my website is on www.42tech.com. So that's 42, the numerals, TEK.com. And a companion site, events.42tech.com. And if you use the contact form on the site, you can ask how I can help with, new product development, implementations, and so forth.
All right. Well, thanks for sharing your insights, and I'm sure we'll be soon.
All right. I'll look forward to seeing you.
Okay. Well, that was episode 94. 2 and a 47. In this case, I like the episode number, but not a big fan of the episode. Oh well. To get an analysis of this episode, links to everything that was mentioned in it, and the transcript, go to the show analysis notes. They can all be found at iot-inc.com/podcast. And note that if you sign up with the long form, then you will get access to all the PDF transcripts for all the podcasts and all the videos. If you've been enjoying this podcast, subscribe to it. That way you'll never miss an episode. And there are 3 ways you can support the podcast. You can share it on your blog, personal or company. That is, if you think others will find it of value. You can share it on social, or you can leave a rating or a review on iTunes. To do that, just go to iot-inc.com/iTunes/. It'll only take 1 click, or maybe a little bit longer if you write your thoughts. I'm your host, Bruce Sinclair. Thank you for listening. Until next time, may your path to IoT business be a disintermediated one.
You have been listening to the IoT Inc. Business Show.